Like, did the date program? What is the date today? Like, 3 today, month is 10. And what is the weekday? Week for maybe like Sunday is equal to 1. Okay, Sunday is equal to 1. What is Sunday? Saturday, right? Sunday, Monday, Tuesday, Wednesday, Saturday is equal to 7. Right, today is 7, right? So I'll be writing 7. I want to store like this. Write down one structure, guys. Write down one structure for this to store to print this. Done. What you did that? Okay, for I want to create a structure. What I want to store it, I want to store this number. This number all like 3 are like integer itself, right? So I'll tell it as integer, integer, and integer. Right? So since it is a day, I'll tell it as day. Since it is a month, I'll tell it as Since it is a week, I'll tell it as WW. Right? I'll store like this. I'll store like this. Only declaration is possible in the structure. So I'll put a block like this. I'll put a block like this, and I'll put a semicolon over here. Right? I'll put what? Semicolon over here. Right? So I'll just tell it as like day. I will tell it day. I will tell it day. I will tell it as structure. Right? Structure. Right? This is how you'll create a structure, guys. This is how you create a structure. Okay, guys, look on here. This is very unique and important concept. Trust me, honest. Okay, you will be never be coming across this. You might have been never be coming across this. Okay, that is what we are dealing with today. Okay, this concept. Okay, so carefully you listen up to this and hang up with me. Okay, you guys hang up with me. So I'll be telling you how we can do it in a more efficient way and more moderate way. Okay, so look on this now. Look on this now. So I'll be going to here. I'll be creating a structure. So I'll tell that's 25, right? So today's 26, right? So I'll plus vi day 26 dot c. I'll tell it. So I'll come to here. I'll just tell it as like hash include stdio dot h, right? I'll just tell it as int main. I'll tell it. Okay, I'll open this and I'll close this, right? So what I do is, right, so I want to create what, like int dd. I will tell it. Next one is like int month. I will tell it. So week should come before that, right? So I'll just tell that's int ww week, right? So I'll put it in a block, guys. I'll put it in a block. And what is important, the semicolon is very important. For this block, I'll be giving a name, right? So I'll be giving a name called as like what is that, day, right? Day. I will tell it. So it is a structure type, so I'll use a keyword called as struct, right? So shall I give a type def, guys? Since you all know about the type def, I'll give a type def also, right? So I'll just give a da as my variable data type, right? So I'll tell it as like type def. I'll tell it like this. Done, guys. So this is done, right? So this is done. Now what I gonna do it? Okay, what I'm gonna do it? I want to declare this variable, right? So I'll just let us da. I'll just tell us d1, right? Da d1. I will tell it, right? Now how do I want to do this? How do I want to store this? Else I can define it. I can directly define it like this. So what is it? What is the day today? 3, and I'll let us 7, and I'll tell it as what is? What I'll be telling it? What I'll be telling? What I'll be telling? What I'll be telling it? 10. All right. So this is what I'll be doing it. So printing is also easy, right? Printing is also easy. Okay. So I can, in this situation, I'll give you one equal shot, right? Either I can print it like this, right? So d1.dd, d1.ww, d1.mm. So you know about it. So in this situation, I'll just tell it as d1. Okay, what it will print it. If I execute this program, what happens is, look on this. Look under this. Hold me one with this. Okay. So oops, what I'm doing it. Okay, I'll do the escape, execute, and I'll compile this. Not worry about it. I have written size of, okay, so it is day 26, right? Day 26.c. Oops, it's an error. Oh, okay, semicolon. Oh my God. Okay, so I'll come here and I'll do that semicolon over here. So I'll come to here, right? Oops, caps lock. Okay, so I'll compile this, right? I'll compile this. Not worry about it. So that's definitely fine. So it is giving you warning, right? So I'll run this. Okay, I'll run this. When I run this, I'll be getting output called as 3 10 10 10. Okay, this only happens when you have the similar data type. Okay, this only happens when you have the similar data type. Got it? This only happens when you have the similar data type. I'm lagging the screen. Okay. Okay, we'll do something for this. Okay, we'll be doing something for this. Okay, now? Okay, I will go according to your screen itself. Okay, the talk of the screen itself. Okay, so I'll be coming to here. Okay, I can even write it. I can even write it. What I can write it, like I can tell it as D1, right? So I can even tell it as D1 dot as you're thinking, DD, right? And again, I'll tell it as D1 dot, I'll just tell it as like WW. I will tell it as WW. And again, I will tell it as like D1 dot, I'll just tell it as like MM, right? D1 dot M. Right, guys? So even in this way, I can actually do it, right? So if I execute this program, so by telling that as a dot WQ, and I'll come here and I will be compiling this and I'll be running this program. So if I run this program, what happens? What happens? It will be giving you output called as what? Output called as what? Like 3, 7, 9, 10. 3, 7, 9, 10. Guys done? So both are correct. Both are correct. Over here, you will be getting a warning. Over here, you don't get a warning. That's it. Okay. This is only possible when you have a similar data type. Okay. My question was not for this one, guys. My question was something I told you, right? You will be learning something new today, right? So, and this concept is nowhere explained according to me. Okay. I don't think so. Anywhere it has been explained in that detail or that important they have given to this topic. Okay. Which I personally give it. Okay. Oh, it was getting 3, 10, 10. Oh my God. It was like that. DD, WW, and MM. Previous output was 10, 10, 10, 10. Oh, I didn't see this. I didn't notice this. That's fine. That's fine. That's fine. That's fine. That's fine. That's fine. Leave it. Forget about it. Okay. Leave it. Forget about it. So let's go for this one. So that is not the actual concept which I explaining today. Okay. The concept is different, which I'm explaining today. Okay. The concept is something like this. Whatever I'm explaining it, it is on the base of the size. Okay, it is on the base of the size. Okay, I'll be coming to here, guys. I'll come to here. So I'll just tell it as the size of, right? The size of D1. I will tell it. Size of D1. I will tell it. So I will close this one. I'll close this one, and I will be printing. I'll put it in the printf block, right? Printf block, and I'll do as percentage LU, right? So percentage LU, I'll set a slash in and I'll put the semicolon over here, right? So what part of the size of this one, guys? What is the size of this one? So very simple, sir. The size of this one, what is the size of this one, guys? What is the size of this one? Pakka, right? Right. So I'm using what? Okay, 12 bytes, right? It's absolutely right, 12 bytes. Now the actual question starts now. Okay, now actual question starts now. Look on here, guys. Look on here. Look on here. Careful look onto this. Actual question, something like this. Now, you have day, you have WW, you have what? You have MM, right? What might be the highest day, guys? Starting from 1 to what is the highest day you can get it? You can get it. What is the highest day you can get it? 31. 31 will be the highest integer number. In WW, right? What is the highest number you can get it? Starting from 1 to what is the highest number you can get it? 7 you can get it. So in the month, what is the byte you can get it from starting from 1 to, you can get it what? 12, right? This is how the highest number I am get it. To write this number, I'm using 4 bytes of memory. For this one also, I'm using 4 bytes of memory, which I'm using 4 bytes of memory, right? I'm using what? 4 bytes of memory. But so much of memory is not actually needed. Not actually needed for to store this. In total, I'm using 12 bytes. In total, I'm using 12 bytes. So this is according to your program, right? In actual, I don't want so much of memory. I don't want to use so much of memory, right? How can I reduce it? Okay, here, if I want to store 12, right? Here, if I want to store 12, I require only 4 bytes, guys. Do you agree with this? 4 bits. Okay, over here I'm using 32 bits, right? 32 bits of memory, right? So I need only 4 bits to store 12, right? Here, how many bits, guys? Here I needed only 3 bits, right? Here, how many bits? Here I needed only 5 bits. Within 5 bits, I can store this, right? Within 5 bits, I can store this, right? For example, for day, I'm using what? 32 bits, right? 32 bits. How much actually needed it? 5 needed it. 5 bits needed it. How many wastage, guys? Waste how much? How many wastage of memory? Like 27 bits are wastage. Correct, right? 27 is wastage, right? So comment here, ww, right? Here also I'm using 32 bits. How much actually needed? 3 bytes I need. 3 bits I needed. How much? What is the wastage? 29 is a wastage of memory, right? So coming here, mm. In mm, it is also using 32. 32. So if I tell this one is nothing but how many bits? 4 bits, right? How much I'm using it? 32. 32 में minus किए तो 4 को minus किए तो कितना आएगा? 28. Right, 28. So much memory I'm wasting it. It's like more than using it, I'm wasting it more, right? 5 times, 6 times, 7 times memory I'm wasting it. So in actual, how many bits I needed, guys? In actual, how many bits I needed it? Like 5 plus 3 is nothing but 8. 8 plus 4 is nothing but what? 12. 12 bits mein kaam khel sab khatam, right? 12 bits. And within this one, everything is done. Listen up here. I know you have never come across this. Okay, majority have never come across this. Okay, so I'll be guiding you now. So look on this. Look on this. I'll be going to the program. Tell me how many bits I want for the day, guys. How many bits I want today for the day? How many bits I wanted for the day? I wanted 5 bits, right? So since I need 5 bits, I'll be putting a colon here and I'll tell it as 5. Okay, so for week, how many bits I needed? 3 bits. I'll put a colon here. I'll tell it as 3. For m, how many bits I wanted it? I wanted like 4 bits. So I'll just colon 4. So this is how you will convert it. Okay, but it will do the round figure, guys. Okay, 12 bits you are telling it. Okay, but it will calculate in the form of what? Like 4 bits. Since it is a like standard form of this one, so it will give you 4 bytes. Okay, so I'll come here. So I'll compile this and I will run this program. So I'll run this program. Right, I will run this program. So when I run this program, look onto this case. So I'm getting it. I'm getting 4 bytes. Okay, I'm getting what? 4 bytes. Okay, instead of 12 bytes, I'll tell you about the minus. What is that minus is? Instead of telling 12 bytes, instead of writing 12 bytes, I'll be getting what? 4 bytes of memory. This is how I'll cut short the memory. Okay, this is how I'll be cut shorting the memory. Got it? Now let's work it on the minus thing. Okay, let's work it on the minus thing. Till here, any queries, guys? Till here, any queries? Just take it on this one. So this is how you will do this. Okay, you will put in just colon whatever the bit you wanted, colon whatever the bit you wanted, colon whatever the bit you wanted. And this can be done by using what? Structures. Round figure. Okay, it is making a round figure because of the bus thing. Okay, because of the bus thing. Okay, even in the 16-bit compiler, the same thing, if you do it, you will get it 2 bytes. You will get it what? 2 bytes. Why? Because integer sizes of 2 bytes and it will do the padding thing and it will give you 2 bytes. Got it? But here the same thing, you're getting it for what? 4 bytes. Guys, done? Till here done? Okay. Now my important concept is you are getting something called as minus, guys. Okay, for this one you are getting something called as minus. All right, I'll tell you about that one also, right? So I'll tell you about that one also. So that one already done in 1947. We have already done it. Okay, but just a recall, I need to do it. 3 minus 1 minus 6. Okay, for 3 7 10, I'm getting what? 3 minus 1 6. All right, 3 minus 1 6. Right, 3 minus 1 6. 3 I have it, minus 1 I have it, minus 6 I have it. All right, this concept is already done, but this just recall it. 3 7, for this one, what is that? Is 10. All right, for this one is 10. Okay, now coming here. This one you have 5 bits. Not to worry about it. This one you have 5 bits. All right, you know how to store. Right, you know how to store. This one you have 3 bits. This one you have 3 bits. This one you have like 4 bits. Right, this one you have 4 bits. All right, if I want to store 3, this is how I'll be storing it. All right, 3 I'll be storing it like this. All right, if I want to store 7, what will happen? All the bits will become positive. If I want to store 10, guys, what I need to do it? 8 plus 2, 10. It is done. Right? This one is nothing but 0, 0. Right? So in this case, what I'm doing is, guys, so you know something called as MSB, LSB. All right. So this bit is act like a most significant bit, and this concept is very much important. On that day itself, I have told you this is acting like most significant bit. This is nothing but most significant bit. This bit is not activated, so I don't want to convert it into 2's complement. This bit is activated. I want to convert it into what? 2's complement. Tell me what you do for the 2's complement. First, you need to do the 1's complement, right? So first you want to do the 1's complement. So you'll do it as what? 0, 0, 0, and then you do the 2's complement by adding 1. So what is the output? 0, 0, 0, 1. Right? In total, you'll be getting what? 1. Since you've done the 2's complement, you'll be getting what? Minus 1. So are you getting minus 1, guys? You are getting minus 1. Right? Here also this bit is activated. Right? You need to do what? 2's complement. To do 2's complement, you need to do what? 1's complement. What do you do for 1's complement? You will tell it as 0, 1, 0, 1. 2's complement, what you will do it? You will add it plus 1. Right? You will add it plus 1. So what do you do it? 0, and you'll carry 1. I'll do it as 1. I'll do it as 1 here, and I'll do it as 0 here. So what is the output here? We get it 6. Since it is 2's complement, I'll add it what? Minus 6. Are you getting minus 6, guys? Are you getting minus 6, guys? Right, 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 right. Right? This is how it is going on to it. This is how it is going on to it. Okay, how to overcome this? Do you get any negative number in the structure, guys? Do you get any negative number in the structure? You won't be getting any negative number in the structure. You know that. Only positivity. To get it only positivity, what I need to do it? What I need to do it? Answer integer. Alright, this is what I needed. Okay, this is how I need the answer. Right? I'll be telling the question, you'll be telling the answer. The solution is done. Alright, so I'll come to here. What I do it? Now I'll be coming to here, day 26. Simple thing. I'll go here. I'll add it what? SIGNED, unsigned, right? Oh, unsigned. Oh, yeah. Okay. So I'll just ask unsigned, right? So I'll come here, GNED, unsigned. Done, guys. So if I run this program, so I will compile this and I will run this. So right? Everything is done for you. So you'll get it, all the things, right? So same thing I'll be doing it here. So I'll come here and I'll do it as like, what is the highest number I can store it here, guys? What is the highest number I can store it here? So if I tell it as like here, I'll just tell it as 31. Here or again 7, and here it is 15. 15 will be the highest number I can store it here. I know 12 is the highest one, but I can still store it 15 over there. Right? There is a maximum number I can store it here, over here, right? So I'll run this program. I'll compile this and I will run this program. So look onto this. So I'll get you 31, 7, 5, 15. I will add plus 1 to all the numbers. So it should become what? 0, 0, 0. Do you agree with me this? Do you agree with me this? Do you agree with me? If I 31 को जाके 32 करता हूँ, 7 को जाके मैं 8 करता हूँ, and 15 को जाके मैं क्या करता हूँ? 16 करता हूँ. Right? If I do this one, right? If I do this one, so I'll compile this, and that's okay, no problem. And I will enter this. So every numbers I'm getting what? 0, 0, 0, 0. So you cannot access the site address of this variables now. Okay, where previous one you can access the address. Okay, here it is not bit addressing. Okay, if I try to access the address of this one, if I try to access the address of this one, I'll get a slap. You cannot access the address of bits. Okay, you cannot access the address of bits. So that is one thing which you need to remember it. Okay, guys. So if I try to access the address of this one, for example, this one, okay, I'll try to access the address. Okay, if you do it normally, you can access it. Okay, normally you can do it, you can access it. P, right? I'll just set it as like this also. P, I'll tell it. Okay, now don't want. Okay, don't want. Okay, so I'll just set it as address of this one. So I'll go for it. I'll go for it for the accessing part. Okay, so I'll compile this. So I'll be getting what? Address of bit field requested. Address for bit field is requested. You cannot have a bit addressing. You will be having a byte addressing. Always remember this. Got it? So we are dealing, it is also telling that it is a bit field. Got it? How many bit field? It is a 5-bit field, right? You cannot have access for 5-bit field. Bit field address, you cannot get it. So you'll get it what? Byte field.